today, we'll start with just an overview of what we're discussing today. Starting our process is it's going to start in ArcGIS Pro. This is where we're going to be preparing our data and creating our new layers. And then moving on from that, we'll share our layers to ArcGIS Online or AGO, and then we will configure our web maps to be used on Field Maps mobile device or mobile app out in the field to collect our data using the DA2 to connect to field maps and then collect our points. So starting with our data preparation, just a quick overview of everything that we're going to cover, starting with selecting our coordinate system. So this is something we do when we're creating our new layer in ArcGIS Pro, and then also enabling ZValues or elevation for our new feature layer. This is also done when creating a new layer. And then after we have created our new layer, we will add GPS metadata fields using the Geoprocessing tool in ArcGIS Pro, and then configuring a couple additional layer properties afterwards before we officially publish our layer to AGO or ArcGIS Online. So getting into the coordinate system, when we create a new feature class, we have the option in Pro to update our coordinate system. This is something that cannot be done currently on ArcGIS Online. The default when creating a new feature layer is Web Mercator on AGO. And so we start our process in ArcGIS Pro, and this allows us to select a specific state plane coordinate system that works better for our location. I believe in the future, you will have the capability to select a different coordinate system, and then you can create your layers on AGO in that specific coordinate system. But for now, we start our process in ArcGIS Pro so that we can choose our coordinate system. After this, we enable ZValues. So here, when we're creating our feature class, you can see we have the ZValues checkbox, and we want to make sure that we have that enabled. This is something that can only be done when you're creating a new feature layer. So for existing layers, this is not a checkbox that you can mark. For situations where you have existing feature layers, you would have to create a new layer and check the ZValues are enabled, and then append your existing data from your existing layer to the new feature layer that you have created. And then doing so will allow you to store your 3D data. And when talking about ZValues, we're simply talking about allowing the store of elevation in the data. And this pairs well with using the DA2 with its vertical accuracy. After we complete our creating our new layer, we move on to the geoprocessing tool, which is called Add GPS Metadata Fields. So when we create a new layer, we don't have any of the fields required to collect all the information and store all of that. So we take our new feature layer and we use that as an input for this geoprocessing tool. We run the tool, it takes just a few seconds, and then it puts in 22 fields which track all the information that is captured with our DA2. So this is an example of the table after we have run this tool. So you can see our example points layer that we created. We had a name field and a comments field, our ID field. That is all we had when we added or when we created this layer. And then after running the geoprocessing tool, we see these 22 fields down here. These are all added while with that tool. And just to highlight a few of the attributes, the receiver name, this is something, so when you collect your feature with the DA2, the receiver name will get filled in with that information. Same with the latitude, longitude, and altitude. All this information is automatically collected. And then the average accuracy, both horizontal and vertical, super nice to have that. So after a feature has been collected, you can see what your average accuracy was. You can see if it was about 1 inch accuracy, or if you had poor signal, maybe this feature was 3 foot accuracy or something like that. Next, just a few more additional properties for the layer before we share. So for attachments, we want to enable attachments on our layer. And when we once we have this checked, we can add photos while out in the field. And then you can also add files or PDFs, things like that, to existing features from the office as well. So if you have easements or PDFs of some sort that pertain to the data of the layer, you can enable attachments and then have those saved as well. For global IDs, this is something that is just a unique ID for each feature that is collected after you have all your features collected. And then editor tracking. So we enable editor tracking, and this allows the creation fields and the editor fields to be visible. And when you create a new feature, you can see who created a feature and when it was created. And then same with editing, who was the last editor and who and when that was last edited. So moving on to sharing our web layer. So after we have all of our everything good to go with our layer, we then move to sharing as a web layer. And after we share, then we can enable editing online, and it can be then utilized in field maps. The share as web layer option, we fill out all the information for our layer, and then after we share, it will go onto ArcGIS Online. And I'm going to move to AGO now, and we can spend some time on the homepage here of a web map. So after we have created our layers and get our layers into a web map, this is going to be the homepage of the web map. You can see here we have all of our layers listed out in our description here. And we're going to talk a bit about Field Maps Designer today. So when you open up Field Maps Designer here, you're going to see the home page, and it's going to give you pretty much the same information about your web map and some different options for managing your web map and customization tools with that. And should load. Here we go. Okay, so we have our same web map, and we are now in Field Maps Designer. And you have all of your summary, who it's shared with, the status, and all that sort of stuff. On the right-hand side, you have Open in Map Viewer. So when you open this in Map Viewer, you then have the capabilities to navigate around your map. You can add features, you can edit attributes. All of your editing capabilities will be done in Map Viewer, so you can access that from this overview page. But we're just going to run through these tabs here on the left today. Starting with forms, and since it does take a little while to load each of these, I'm going to, I already have them open, so I'm going to move from tab to tab, starting with the forms. With the forms, this brings a lot of functionality in from like Survey 123 and things like that. I'll show just a couple of examples of what you can do, but there's so much to cover with this just forms tab in general. We have previous webinars on this sort of information, so feel free to check those out. But for today, we're diving into our fire hydrant layer. And if I select one of my fields on the right here, and I pull in, let's say, my manufacturer, you can see I am now editing this, formatting this attribute. And so right now it is a drop-down list. Something simple you can do is update the formatting to like radio buttons, for example, and you have the option to do this and have this as an option, or you can have it as a drop-down list there. So that's something that is very customizable, formatting your attributes. Logic, the logic section, I also want to talk about here and highlight just the functionality of this. You can make your attributes editable if they are a required field, and then you can use arcade expressions to really customize and simplify your workflows. A great example of using this logic system is if you have like a needs attention field for your feature class, and you have that marked yes, as in this feature is in poor condition or it needs attention for something like that. The logic field, you can have it input to when that is marked yes, you can have a comments field or a notes field pop up and have that be required. So if someone says that this feature needs attention, you can have it be required and that they put in a comment of why they mark this as needing attention. Next, we'll move on to Geofences. So for Geofences, this is simply allowing you to select an area and then send alerts to your mobile workers. So when we add a geofence, you can choose a specific property or even a specific building. And when you add your geofence area, you can name it. And what you're allowed to do is put in a location alert. So on entry or on exit or both, you can have a message pop up for your mobile workers on their iPads, on their mobile device, saying, hey, caution, and write out your message, whatever you need. And you could also have location sharing. So when they enter or exit this specific area, you enable location sharing from their iPad and keep track of the progress and everything that way. Next, we'll move to offline. So the offline tab here is a way to download an offline area of your map. And this is basically a cutout that is completely offline and downloaded onto your iPad. It's fully functional. You can edit, you have the ability to edit attributes, to add new features, to collect photos, everything that you can do typically in your web map, you can do in an offline area. So super useful if you are out in the field and you know you're going to be in an area with poor signal, or you just may not have access to Wi-Fi on that current day. You can set this up, and this pairs really well with the DA2. You can use the DA2 completely offline. Once you activate your Catalyst subscription for the day, you can pull a full day's worth of hours out, and then you can use the device with the high accuracy without any Wi-Fi, pairing really well with these offline maps. Moving to our next tab here, so we have our app settings, and we're just configuring the default settings for mobile workers with this specific web map. And today we'll just touch on this collection setting here. So starting with accuracy, this is something that we set up on the iPad in field maps, but now you can access these settings and apply them to the web map as a default before your workers even get out into the field with their devices. So for accuracy, this is just a threshold. When usually I'm out in the field, I set this somewhere around 6 inches. And what this does is while you're averaging with the DA2 and your accuracy sitting at about 1 inch or so, if you're under some tree cover or for some reason weather-wise, your signal jumps up, it will automatically pause what you're averaging, and it will allow you to not have to be so focused on, okay, is my signal going to jump up and my accuracy is going to get thrown off? It will pause your averaging, and then it will allow you, or it will automatically resume once your signal gets better. And this GPS averaging, I usually have that checked on as well. It basically averages a position every second while you're out there with your device. You have it centered, you hit average, and then it just 1, 2, 3, 4, 5, and then it saves. It takes a bit more time, but this allows you to get just slightly better accuracy. So if you have about 1 inch accuracy and you do the GPS averaging, you should see about 0.5 inch accuracy. So slightly better than what you would see if you just shot the point real quick. But you also have that option to turn that off if you're in a hurry and just want to collect a feature real quick. Next, we'll go to streaming. So this is specifically for line features. When you have the DA2, you can stream a line instead of just creating point to point. And this will add a new vertex as you walk. So you start streaming, then you start to move. And if you have it based off of distance, you can have it add a new vertex every 10 feet, or you can have it based off of time as well. So every 5 seconds, it's going to simply add a new vertex as you move with the device. So it'll follow you in your high accuracy and create a line feature as you move. For fixed type, so this is just a default of the threshold of the GPS locations. So typically if you have good signal, you're going to get RTK fixed with the device. But if you want to have anything else as a threshold, if your signal drops down or something like that, you can have that applied. Usually any is fine as a default. For collecting new features, usually it's going to center the map around you when you add a new point. If you don't like that or want that changed, you can do that here. And then for manual location, so this is pretty interesting. When you have the GPS connected, you're shooting your points. Maybe for this specific map, you don't want to allow people to update a feature without the GPS. So you can block that entirely, or you can warn and pop up a message and say, hey, you don't have your receiver connected. Are you sure you want to manually update the location of this point? So that is something that you can add in your map here. We have a couple other things. Snapping usually is turned on. That's something I'll showcase in the next video that we go over, snapping line features, and then photo upload size. So as you collect features, you can choose the size of the photos as well. But we'll move back into our presentation here. And now I have a video that I'm going to talk over and kind of just showcase pairing the device using the Mobile Manager application to activate your Catalyst hours, talk about the subscription itself and the high accuracy that you get with that, and then just collecting and editing some features in field maps. So on the home page of our iPad here, that's usually where you'll start, and you connect to the DA2 via Bluetooth. So you don't have any wires from your iPad to the device. It's all wireless via Bluetooth. And then you open up your Mobile Manager application, and this is where you will find and access your Catalyst subscription. So typically, you're seeing a block of hours here on the screen. So this 93 hours shows you how many hours you have left available in your pool. So when you have 93 hours and you go to start 1 hour, this is what gives you the high accuracy that you're paying for with the device. So you have this option as a pool of hours, or you could also do unlimited time for a specific cost per month, and you have unlimited access. But typically, when you want to get out there with the device, you start 1 hour from your pool, and then you can continue working. There we go. Okay, so after you have activated your hours and you start your session, it's going to pull an hour from the pool, like I had mentioned, and you'll have 1 hour available at that time. You can extend that. If you know you're going to be out for the day, you can add multiple hours onto there. But at a minimum, you use 1 hour at a time. And then you open up Esri's field maps, and it talks to the DA2 in the background through the Trimble application. And here we have our map pulled up here with our GPS details in field maps, and we are connected to our Trimble DA2. And you can see our accuracy is not too great right now. We do have satellites though, but we have just opened our app, and so we should see our accuracy increase or get better as we wait. And so you can see up at the top here, now we have a 1-inch GPS accuracy. So we're good to start collecting some features. We're opening this first point here. So we're in a sewer map, and you can see we have a sewer manhole point here on the map. And we are looking at the attributes of this feature, and you can see we have information already filled in. These are the metadata fields that we were talking about previously with that geoprocessing tool. These have been added, and this has been shot already with the DA2. You can see we have the receiver name filled in. We have all of our lat, long, and altitude. So we know this has been collected before by simply selecting that feature. So we're going to select the next one. And as we scroll down, you can see we don't have any of that information filled in. So this is a feature that we know needs shot while we're out here collecting our features. So we edit this feature, and then we start averaging our location, and it will average across the top. And at the end, we're going to get an average accuracy, so 0.5 inches. And then we can snap a photo real quick. So we are snapping a photo of the lid. You can use photos for any sort of information that you need to capture. And then we can immediately go into editing attributes of our feature. So you can see we're selecting cone type, surface type, cover shape, things like that. All of this information can be filled in before we've even initially saved our feature. Now we're going to save it, and its location is updated along with all of the information. We're going to unselect it. And just to make sure that everything's saved, we're going to go back into it. You're going to see the receiver name and all of our information is filled out now. And we can check and make sure our photo is still there. And it is. We've added our photo successfully. Now we can move on, continuing with our workflow. So now we're going to go and update this line segment here. And we're going to utilize that snapping function that we were talking about. And we're going to snap this line directly to the new location that we shot. So typically this makes a clean product where you use the GPS and shoot the lids of the manhole location, and then you can snap your gravity mains cleanly to those points and know that everything is GPSed. If you have your points shot and have a good accuracy with those, you can snap your lines without any issue. And then in the video, we move on to the next feature here. And we open that up, and we are going to do the same process here. So we're going to update the location with the DA2. You can see our accuracy is still at about ½ an inch, and we do our averaging. It updates the location automatically, and then you can go through the same process, taking the photo, updating any attributes that you need to, all in one place. And I'm gonna speed through this real quick, just for time. After we have made our changes in our sewer map, we can simply, in this case, we saw something out in the field for water that we need to collect. So we are moving out of our sewer map and into our water map. Super easy process. And now we have a completely new map open with new features. We're not going to see any of the layers that we saw before. All those sewer features are not visible anymore. This is a new map just for water. So we have a hydrant point here on this new map, and then we can go ahead and, for our list of features, scroll through all of our water features now and select, there's a valve out here that we decided to collect. So we collect this valve and take a photo of this as well. And photos, like you can take a photo of any feature that you collect, or you can use photos specifically to showcase like something's damaged, something needs replaced, things like that. Typically, you will also find just the general notes field or a comments field is super useful to have on most of your layers as well. And in this example, we're selecting this fire hydrant, and we're seeing that we have already shot it in the past. But the only thing we are missing in this case is a photo. So we're going to snap a photo of the fire hydrant here and make sure that all of our information is up to date. This feature was already collected, but we can go in and edit any of the attributes and snap a photo to an existing feature as well. And that will bring us back to our presentation. This page is just showcasing the different options for the Catalyst subscription. So these are different accuracies, starting with what we were showcasing, the 1 centimeter accuracy. It's going to cost a little more. The pricing changes, but if you want less accuracy, you can pay a little less to have that. So something like the 10 centimeter, 30 centimeter, if that works for you or your organization, you can choose that instead. And if you're collecting something like sewer lids, you're going to be able to find the feature pretty easily with the lower accuracy. But if you're collecting something like water shutoffs or like the curb stops, you may have trouble finding those with the lower accuracy, especially if they're buried. The data collection processes. So what we're showcasing is more like the connected approach, where you collect the data and then everything is live on AGO, ready to go and be shared. So like when you collect these features out in the field, you can have somebody on the web map in the office, seeing the features live, updating for them, where the old way, and what I used to have to do is the disconnected process, where you would collect the data, and then this is stored internally on the GNSS receiver. And then at the end of the week or day, you have to go process this data. So you're offloading at the office at the end of the week, and then you're outputting like a shape file or something like that. And then you upload this shape file, and then everything is live. Everything is in one place at that point. So a little bit lengthier of a process, versus just collecting data and having it available to everybody immediately. This is the data collection bundle. This is what we provide for getting you set up and ready to basically do and collect all of the utilities that you have and show what I showcased in the video. This basically gets you set up and ready to do that. So the hardware on the left here, the DA2 itself with the batteries, the pole, and the data collection kit, so the iPad case and pole mount. And then on the right here, you have the software. So training for all of your applications, the downloading of the applications, and then the hour pack here, the Catalyst subscription that we were using in the video.